the meat of what we're actually talking about today is those last three. The first thing that's up there. All right, so you should see a picture like that on page 60. And again, I didn't copy, I don't have the words from there because all this is coming from my stuff. And what I'm going to draw up here, I'm just trying to have the sketch that's in your guys' book so you at least have a sketch that corresponds to what we're talking about. All right, so I'm assuming they have a definition in there. I'll have mine up there as well. So a transversal is simply a line. It's just a line that fits a given condition, which in this case, the given condition for something to be classified as a transversal is that it goes, or that two lines are going to intersect it, but at two different points. So the whole two different points thing, or the different points, is key here, because if it's at the same point, like if I had a line and then two others intersecting it at the same point, you would have a picture that kind of looks like that, which all that's doing is creating a bunch of vertical angles and angles that add up to 180. Whereas this thing here, like, so this line would be the transversal. These would be the two lines intersecting with it. So that would be different points as opposed to the single point that's there. Now, the letters they have, A, B, C, D, E, F, G, H, they're labeling all those angles because we're going to have specific names for certain angle pairs up there. Different from ones we already had. Like, you should already have names for, like, those two together. Right? Those two together yesterday, if they're opposite each other and two lines are crossing, those are vertical angles. So that I'm considering that an old word because we did it yesterday. Okay, so it's something we've already talked about. I could pair these two together right here. And what is this called if they're paired together and they make a line? Linear pair. Okay, so these terms, guys, you better get those terms down. You have to know how to identify those. You have to know that vocab. If you do not take the time and figure out that vocab and like ingrain it in your head, it's not going to work out too well for you. Okay? It's your warning for it now. I'm telling you now. You need it. The vocab here is huge. You need to get it down. All right? So these two pairs are ones that we would have talked about yesterday. Okay? And everything, all the properties we had still apply. Like these two together still add up to 180 because that's what a linear pair does. And up here, I know those are equal to each other because vertical angles are still equal. Okay? So all that still applies, which they probably even have questions in the book asking about which ones are equal and which ones are supplementary at some point. And at this point in time, all that you can answer are going to be things that related to what we had talked about yesterday. So all the linear pairs would be supplementary and all the vertical angles are equal. Okay? Now, the new ones that you're going to have, there's four names that you're going to have to or four classifications that you're going to have for the other angle pairs. Okay, and I'll write them out. Now, the other angle pairs are going to be ones where you're taking an angle at this intersection point and pairing it up with one at that intersection point. So when they ask you about transversals and angle pairs, like if you see those words together, they're going to be asking you to take an angle at this intersection point and pair it up with one there. So all the ones that were at a single intersection point would be your vertical angles and linear pair. If you take one here and match up with one here, you're going to have some other terms that come along with it. All right? I guess I'm assuming these are all on the same page. I don't know. Okay, so the first one, I don't know why I put that up. So the first one is going to be called alternate interior angle. I'm just going to write these out. Angle. Okay, now in terms of the way this transversal thing works, these two lines that are intersecting, all this space in between them is considered the interior. Okay, so anything that's enclosed between them, even if I have, I can have this drawn sideways as well. So if I had that being my transversal, and that being like L1 and L2, like if I turn it sideways, this space here is the space that's enclosed between them, so this would be considered the interior for this specific situation. Everything else is the exterior. Okay, now I'm pointing that out because the naming of these pairs tells you where to look to find the angles you need to match up. Okay, so for the first name, it has the word interior in it, so that means I can only look at the 4 interior angles, which are C, D, E, and F. Okay, so I'm going to match up either C or D with E or F. So again, I'm picking one up here, and I'm matching it up with one down there. All right, let's say, do you want to start with C or D? D, fine. Okay, so if I'm looking at D, right, the alternate thing is just saying match it up with the one that's on the opposite side of the transversal. So if I look at D, D is on the right of it here. So they're matching it up with E in there because that's on the left of that line. So C and E would be considered your alternate interior angles. I mean, D and E, sorry. Okay, and then if I match C up, so again, same kind of idea, right? C is there, C is on the left side of that transversal, so I need an alternate one, which would be on the right, because it's opposite. So C and F. And again, I don't pick anything from A, B, G, and H would not fall under that classification, because they're on the exterior, not the interior. All right. Now, so that'll lead me to this one, which is the alternate exterior angles. Okay, so again, if I wanted you to tell me, hey, there's a picture there, tell me a pair of alternate exterior angles. That means that one, you would have to only pick from the ones that are on the exterior. So that means I'm looking at A, B, G, and H. And again, alternate sides mean if you look at one that's on the right, pick the one that's on the left. Those are opposite sides. That's what the alternate means. So alternate is just saying look at opposite sides of that transversal. So if I look at angle A, that's on the left. Which one would I match it up with down here? H, because it's on the right. So A and H. And then B and G would be the other ones. And that's it, because that's all the exterior angles I have. Okay? I'm going to do this one next. So same side interior angles, which also you could call this consecutive interior angles. You might see that name also. It means the same as this. So again, this is telling me to isolate and look only at the interior angles. But now I want ones that are on the same side of the transversal. So if I pick one that's on the left, I better pick another one that's on the left. Right and right, so on. If I was looking here, it would be ones that are on the top of it, matched up with the ones that are on the bottom. So again, I would focus again only on the interior ones. So C, D, E, and F. If I look at angle C, I'd have to match it up with E. Those two together would be considered same side interior because they're both on the left of that specific transversal. And then D and F would be the other ones. Okay? All right. The last one is the corresponding. Corresponding always means the same thing. It doesn't matter what part of the book we're at or the course. Corresponding always means that it's sitting in the same position. Okay? Now, you got to remember the way these things are paired up is I'm taking one angle here and matching up with one there. Okay, so corresponding, again, means, like if you want to make a side note, do it, but corresponding always will mean it's in the same position. All right? So we'll do this. Out of A, B, C, or D, which one do you want to pick? 3? A? Okay. So if I look at A, in relation to this point here, This is like up and to the left, right? It's like the upper left-hand one, correct? So if I go down here, I've got to do it one that's sitting in the same position. So I got to go up and then to the left. That'd be E. So A and E would be an example of corresponding angles. The other way that I tell people to kind of think about it is if I were to just take all of these out and like cut it out and just put it right on top of this thing, all the ones that are going to be overlapping are going to be considered corresponding angles. So if you can imagine cutting this part out, picking it up, slapping it right on top of that, A would be there. Which one would be with F? This would be, and that'd be C. Okay, so if you took that intersection point and stuck it on the other ones, those ones that are overlapping are going to be the ones that are the corresponding angles. So you can either look at it as like a quadrant, like it's the upper left-hand quadrant or something like that, or you can just visualize, hey, it's sliding down to the other spot. Okay, now, so the two things you're going to be doing is, with just this, is you're going to have to identify, like they might have a picture, and they might give you two angles and say, which ones are they? You'd have to match it up. Or I might give you the picture and say, name me a pair of alternate exterior angles. And you have to look at the picture and pull out specific letters. Okay, so we'll do this first. All right, so we'll start with like the first one. That's on, oh, I didn't write the page. This might not be in your book. You might have to actually write this. I might have pulled this from somewhere else. What?
It's not in our book.
Draw it out.
Draw the finger?
I would recommend writing out the example. Either this one, well, this one and the next one. So this would be the first kind of problem you would see here. So there's a picture there. I'm giving you pairs of angles. And when it says relationship, what I want is I want the, like the classification. All right? Now again, they're pairs of angles. So that means that if you were to make like a word bank or something to pull from, anything that we have is like pairs of angles, like name-wise, could apply here. Like I can have vertical angles, right? I can have a linear pair. I can have the alternate interior angles, which we just did, alternate exterior, same side interior, or corresponding angles. Okay? Now I wouldn't use like complementary and supplementary because that's more of like throwing a property to it, which the only way you would get it from there is if it was like a linear pair. So that I wouldn't expect. All right, and if it doesn't fit any of those, like if it doesn't fit any of those, yeah. Why are you asking about that? Huh? For 1 and 7? All right, so for 1 and 7, if you look at them, so 1 and 7, they're not vertical angles because they're at different points. So like these two right here have to be at the same intersection point. These have to be at the two separate intersection points. But 1 and 7, he's asking, are the same side exterior? Well, we don't have that classification. So I'm just going to put a none there. Okay? Because we don't have a name for it. It's just that they are there, which is fine. It doesn't fit any of these titles over here. So I don't have a relationship between the two. Okay? Now, when we get to problems with like parallel lines, we could tie things together, but there isn't like a flat out same side exterior angle that we deal with here. All right? So 1 and 7 would be none. What do you think for 1 and 8? Yeah, these would be alternate exterior. All right, because if I look at them, 1 and 8, they're not in between. Like this would 3, 4, 5, and 6 are your interior because they're in between those two lines. All right, so I know it's on the exterior, and they're on opposite sides of the transversal, so I knew it was the alternate exterior part. Okay. What about 2 and 4? Hey, you already answered. 2 and 4. Anyone else make a guess? Yeah. This would be a linear pair, right? Because they are. It can't be any of these because these have to have different intersection points. These are at the same, and I know they're not opposite each other. And they're making a straight line, so it would be a linear pair there. All right, what about 3 and 5?
They are corresponding interior.
No. Wait, we don't have corresponding. It's got to be one of those.
Same side.
Hey, same side interior. There you go. So same side interior. Because again, they're on the inside. They're both on the same side of that transversal because they're both off to the left. What about 3 and 8? Remember, you're picking from here, right here.
Alternate exterior areas.
Is 3 on the exterior? No. Can't be that because 3 is not on the exterior. If they're if they're corresponding, they'd have to be overlapping. Like if you pulled that down right on top of it, which I wouldn't say 3 and 8. 3 and 7 would be corresponding because 3 and 7 are both like in that bottom left quadrant. What? Yeah, I'll put that there.
Yeah, I got it.
Hey, there you go. Doesn't fit anything else. Remember, vertical have to be at the same intersection point. All right. What about 4 and 6? Same side, so same side interior. About 4 and 7. It's what? None. About 5 and 4. We'll go quicker now. They're alternate what? Interior. Yeah, because they're both on the inside, but they're opposite sides. How about 8 and 5?
Corresponding.
Is it vertical or corresponding? Vertical, right? Because they're 8 and 5 are at this same intersection point. They're opposite each other, so there's vertical angles. And what about 8 and 7? Are you looking at 8 and 7? Linear pair? Yeah? Okay. Who said corresponding? I didn't. Oh. If you've got problems where there are, what, you got a question on those two, or what about it? There's none that are alternate exterior. On 23, or any problem in the future with this stuff where you see a line, a transversal crossing multiple lines, guys, it's when you pair these up, pair means 2, right? So that means you're only looking at 2 of those lines crossing at a time. Eliminate the one that you don't like, mentally erase it or cover it up with your finger or something if it's not involved. Meaning that if I looked at angle 1 and 2, so angle 1's at this intersection point, 2 is there, that line matters none to the problem when I'm classifying it. So kind of just eliminate it from your mind or cover it up so that if I look at it within the realm of these 2 lines, this is my interior, that's my exterior, if I had to classify it that way. But 1 and 2 are corresponding because they're both, if I slid this right down, they'd be overlapping each other, so I know they're corresponding. Okay? If I wanted to do 3 and 4, like angle 3 is right there, 4 is right there, that line doesn't matter. Because that line's not at my intersection point, so erase it. So that I understand that this is interior, here's my exterior. Those are same side interior because they're both on the same side. And then likewise with 5 and 6, 6 is right here, 5 is right there. This line doesn't matter. Just get rid of it. 1 and 4 don't exist if I'm looking at 5 and 6 together. because they're not at either intersection point, so I don't need them. So they're on the interior here. They're on opposite sides, so those are alternate interior angles. Okay? But the idea is if you've got more lines than 2 crossing that transversal, you're only looking at 2 at a time because you're dealing with angle pairs. So you would eliminate the line that doesn't apply to the problem, okay, or whatever you're needing to work with. So you can either do it with like covering up with your finger. You got a book you can write in. If you see it, cross it out. I don't know, you can write all over your books. It doesn't matter. Okay, so whatever works best for you. All right. What? Are they? I don't know. Okay, so the next thing, those pairs that we had, we're going to extend into parallel lines. Because if you look on those pages, and I'm going to have the theorems written out also, you should see 4 theorems. All right? Over the course of that, there should be 4 boxes. At least 4. Okay? Each one of those is going to give you a property that deals with those pairs of angles that we just talked about. So alternate interior angle is going to have a theorem, alternate exterior, corresponding, and then same side interior. But this is only going to deal with a transversal going through parallel lines. If you do not have parallel lines, which remember the little arrows, when you see them mean that they're parallel, then none of this that I'm about to talk about applies. So if those 2 lines like mine are R and S, if they are not parallel, just forget all this stuff exists. Okay, so the lines have to be parallel for these things to exist. All right, so in the pictures, if you see the parallel lines, this is one of the times where if you look at it and they look like they're the same size, that's because they are. Okay? Like I could go up here and I could say, that's an acute angle, correct? Is that an acute angle? Well, I know they're equal because they're vertical angles, but is that an acute angle? Is that one? They're all the same measure. 4, 6, 2, and 8 all have to be the same measure. Now, we have theorems that allow us to set it up in postulates. Like the first one is the corresponding angles congruency thing. It's just saying that if you have parallel lines in a transversal, the angles that are corresponding have to be congruent to each other. Like angle 3 and angle 1 are corresponding angles. They're both obtuse. Those are parallel lines. 1 and 3 have to be the same measure. Okay? So now, what I have here, this little thing in parentheses and the titles of those little boxes they have there, you guys need. You will have to know the names of those. So if you need to like highlight it, or circle it, star it, something in that book where they have the little things that say alternate interior angles theorem, you need to know that. Like you need to know the title of it. Because when we go about writing these formal explanations, if you set something up, like if you set up, hey, I know 1 and 4 and 2 are congruent to each other, and you do a problem where you set angle 4 equal to angle 2, and it asks you to justify it, you have to say the corresponding angles congruency postulate. Right? Those are words you're going to have to do. You're going to have to pull those out. All right, so if I roll through them quick, the idea is that all the corresponding angles are going to be congruent to each other, which that one is on, that's on that first page, the 66. Okay? 66 should have all the ones that are congruent, which is the same order I've got them in, I just have them flipped a little bit. So all the corresponding angles are congruent, all the alternate interior angles are congruent, okay, which again, this is on 66. So if you don't necessarily need to rewrite it, you can if you want. Right? It doesn't matter though, right? Still means the same thing. Okay. So, and then the alternate exterior congruent, which again, like I said, hey, if you just look at these, as long as you see 2 lines being parallel, you have a transversal, all the ones that look like they're the same size are the same size. It's not like a trick. Sometimes these are not drawn to scale and they just do that to screw with you. This is not one of those cases. Now, I have it listed, and they have all the congruency listed on the same page and listed first. because probably in terms of how you're going to apply these, you're going to work with things that are equal to each other first. Just because setting up an equation where you have one side equal to the other is much easier than trying to add things together and make them equal to 180, which is what the last one is. So that one that's on page 67, the same side consecutive or whatever. What the heck did I have that one? The same side angles theorem is just saying that if I look at the two angles that are on the same side, so that'd be 2 and 3, that's an obtuse one, that's an acute one. If you add those up, it'll always be 180, because if you look at like the linear pairs together, like if I looked at 1 and 2, I know a linear pair is 180. That's the obtuse one, and that's the acute. And all the obtuse ones are the same measure. All the acute ones are the same measure up there. Okay? So now, there's like two different ways we're going to apply this. One is going to be, you got a picture, there's a transversal there, and they give you that you've got two lines that are parallel to each other. And as long as you see these two lines being parallel, you can apply those four theorems. Like you can look at it and go, all the small angles are the same measure, all the big ones are the same measure. The other way it's going to be approached to you is they're not going to tell you those lines are parallel, but they might give you some information about the angles, and they'll say, is there enough information for you to determine if these lines are parallel? Basically saying, does it match up with any of the theorems that's there? So like, if I gave you, did I scare you? Jeez, man.
You're dumb.
So like, one problem, just to keep this easy, I could do like 2x, and I could do 40 there and say, solve for x. And I could go, okay, there's a marking there and there that mean that these two lines are parallel. If these two lines are parallel, that means that these acute angles have to be equal to each other. So I could solve for x by just going 2x equals 40. And if I had to justify it, I would say that these two are alternate interior angles. Alternate interior angles have to be congruent if those lines are parallel. Therefore, I'm allowed to do that. So that would be one type of problem, is solving things out like that, where you're matching up all the acute ones and the obtuse ones, and either setting them equal to each other, or like on this one, you'd be adding them to 180 if they're on the same side. Okay? But again, that would start you with parallel. The other way you're going to be dealing with these, which we'll talk about more tomorrow, I don't know, give me a number.
7.
No, like an angle measure.
4.
4? 36 is better. I like that. We'll do 36. 36. Okay, so in the picture up there, there's a transversal. I've got two lines. I've got A and B. And I got one angle measured. And remember, that's your symbol for parallel. And they'll say, okay, based on what's marked there, do I know if A and B are parallel?
Yes.
If they ask you that, what it's saying is, those four theorems that they have, just go back through them and see if what's marked there matches up to them. Meaning that this angle here, these are both on the exterior, right? They're on opposite sides, so I know those are alternate exterior angles. And if you look at the theorem in there, it says if the lines are parallel, the alternate exterior angles have to be congruent. Are the angles that I marked, are those congruent to each other? Yeah, they're both 36. Okay? So for this, you would say yes, and your reason would be because the alternate exterior angles are congruent. That's your two types of problems. Now, they could make it a little bit more complex, but at their base, that's the two types. Yeah. Yeah, it's the converse, but we're getting into that tomorrow. Okay? Okay? You probably want to draw this out. Here, I'll pull this down for a second.
Can't see.
I will tell you that there's two transversals here, right? There's your two parallel lines. You've got one transversal here, which if I needed to use that, I could take this 113 and I could put it down here. It's also right there. the one right next to it, which is 113 minus 180, is 67. All these acute angles that go along with it are also 67, which I will use, okay? But since the angles they're asking about, VHT is right there. QTS is right there. And then ZHQ. Yeah, ZHQ is right there. Okay, I'm actually probably going to find that number first. No, you don't. A is not 113. Okay? The numbers that are here do not transfer straight over because those are two different transversals. All right? So like I said, none of the angles they're asking about are at this intersection point, so I don't care about it, meaning that transversal, in terms of matching it up with like alternate interior, alternate exterior, and corresponding, don't matter here. The way I'm going to get my numbers is I'm going to look at this triangle here. And generally it's assumed that as a prior knowledge, people get the idea that these three angles in a triangle should add up to 180. Okay, so if I get two of them, I can find the third, which is what I'll do first. Because this angle here and this one here equal how many degrees together? 180, because that's a straight line, right? That right there is my semicircle. So if I do 180 minus 95, that'll give me 85 right there. Then if I take these three together and add them up, like so the one I listed as C, since that's a triangle, it's equal to 180. What's 67 plus 85? What is it?
4.
2. Okay? And then if I subtract the 152, what's 180 minus 52? Okay, so look, now I've got that answer. So that's the last answer down there. Okay? Now I can use the whole transversal and linear pair to answer everything else. Because since I'm going to, I'll leave it. So look, since this line right here is a transversal to these two lines that are parallel to each other, that means that along that line, at these two intersection points, all of my acute angles are going to be 28. 28, 28. Okay? You have to travel along the transversal to be able to like just transfer the numbers down. Now the other two, A and B, they're going to be equal to each other because again, they're on the transversal and they're the obtuse. All I need to know is how many degrees it is by adding those two together and setting them equal to how many degrees is that? Well, it's 180, right? But this ends up being 152 because 180 minus 28 is the 152. And again, I can go along all the obtuse ones along this transversal that hit at those parallel lines are going to be equal. All right? So there's a little bit of trick to this just because you had to, well, that's horrible too. What am I writing? Just because you had to know a little bit with the whole triangle stuff to kind of get this problem